Hi everyone, welcome to Math Spellbook. I'm your host Peter, and basically we are going to try something a little different with our study method. So I remember last night, I was watching a video about studying tips as well as how to study efficiently for for your own your own benefit. And I was thinking, you know what? Every time when I try to study, I try to do the typical thing that everybody else does, take notes and try to remember the details of what I read and everything like that. But at the same time, I remember the stuff that I remember most when it comes to math or physics is that I remember reading the parts that actually appealed to me, or the things that I felt oh, that's cool. But I don't remember all of the gritty details that I usually would see in paragraphs and stuff. So I thought maybe I have to change my study method. And so thinking about it for a while, I thought maybe I should just go back to the basics and try to unlearn what I've learned, but then learn in the way that I feel is probably right for me. So I remember I would do Khan Academy, and I think the reason why I would go back to Khan Academy as well as brilliant.org whenever I feel I want to actually try to get in touch with something, is because they kind of make it so you do problems to test yourself out, but they don't give you too many problems where it feels it's overwhelming. But it's I guess it's sort of a teacher's way of basically saying okay, you just have to understand how to do these problems and you're pretty much good for this particular topic. So yeah, so that's basically what I really wanted to get back into. So I really want to do physics, but at the same time I don't want to do the typical route where I just do kinematics, because I've done kinematics over and over again. Forces, energy, power, work. Maybe we'll do work because they have videos about kinetic energy. I feel I just want to actually, let's try to do a test. Let's try doing this. Let's just try to do some practice. So first of all, I just want to actually, where did I put the study timer? Okay, the study timer's right there. So I think what I can do, I'll be probably moving the chat a lot today, so I will probably move you guys over here this time. Of course, this stream slash video, if you're watching this on YouTube, it's not sponsored. I just feel I want to actually get some practice in. So, all right, so let's get into it. All right, so ready to practice? Let's go. Okay, and I also have some sheet of paper with me, so if I need scrap paper, I can basically use it. Okay, let's see. A constant force is exerted continuously on a block that's initially at rest on a horizontal surface. The block slides with negligible friction for equal distances, d1 and d2, as modeled below. Which of the following quantities are equal for the two intervals d1 and d2? Okay, so the block has negligible friction for equal distances. So we do have a force, so it's basically so the force is pulling the block across these two distances. So, okay, which of the following quantities are equal to the two intervals d1 and d2? The blocks change in speed. The blocks change in kinetic energy. The work done by the force not on the block. Okay. So let me just open up Meedle for a second. Let me drag this down here first. I'll just minimize that. Just expand this. And let's just drag this all down here. We don't need to see my previous work from last stream. Okay. So we do have a block, and it has a force. We have D2 and D1. So the question we had is, which of the following quantities are equal for the two intervals D1 and D2? So I mean, energy is conserved. So if we think about work done, it's basically the force times the distance that would equal work. And also we have kinetic energy, which is, we'll just label it K for kinetic energy. Make it, I don't remember what the proper lettering is. Is it U? Because I know V is potential. And that's mass times acceleration squared, so that's kinetic energy. And we know energy is conserved. And we know force is MA. Don't forget the vector there. So now the question is, which of the following quantities are equal for the two intervals? Oh yeah, and we also have to add to the point, negligible friction. So it's negligible friction equal distances as the model flows. So I guess the friction is like not really that big a deal, but it's also like, I guess it's a constant there. I get a feeling it's B, but at the same time, let's see the block. Well, if it's being pulled by a force, then basically the speed is gonna continuously change. So it's asking which of the following quantities are equal for the two intervals. I feel like it's the energy, but let's see the work done by the force on the block. But the thing of it is that can you maintain that same acceleration throughout the whole entire journey though? It doesn't feel right to me. Yeah, something to, like, it feels like it's the kinetic energy though, but then again, kinetic energy also has velocity in it, and velocity can change and it can vary, but then again, energy is also conserved. Let's see, physics reference information. Let's see what's here. Oh, it's just writing the equations we have. Okay, so... Oh. Okay. So the difference between kinetic energy is between the work that's done. So... Let's see, work done... Force... I'm guessing this is force parallel to the distance, which is... Okay. I kind of forgot about this part. Like this part right here. So... So we add up the amount of work that's done. So from D1 to D2, so that sums up together. So we got work done, and we have kinetic energy, and we have the difference between kinetic energy. I'm gonna pick B, because it seems like it's pointing towards kinetic energy, and plus energy is conserved. I mean, but at the same time, but I don't think the speed is the thing. And the work done by the block, I think that changes with the distances. Let's see. Oh, no, we're wrong. I hate that. I hate that. But, you know, that's how we learn. So if it is kinetic energy, because it shows a lot about kinetic energy, so... Oh, we have to click on all the answers that apply. Okay. So... These two? Work done. Let's see. Oh, it's one of those questions. I thought it was just pick one. Oh, all of them are correct. Oh. Wait, hold on. Correct. The blocks change in speed. Oh. Okay. So constant force exerts continuously on the block that's initially at rest on the surface. So the blocks change in speed, and the blocks change in kinetic energy, and the work done by the force on the block. So all of these answers apply. Oh. I thought it would basically say like try again or something, but I wonder why it let me have correct with these two, even though this one is also included. Let's see the next question. Okay, which of the following statements about translational kinetic energy are true? Assume kinetic energy refers to the translational kinetic energy. So I'm guessing translational means like summing up all the work that's done. I'm guessing. That's what I think it is. Choose all the answers that apply. Kinetic energy is a vector with the same direction as the velocity. Well, yeah, because it is half. Well, technically, it's the same direction, velocity, yeah. It's the same direction as the velocity. It's possible for two objects that are moving at the same speed in the same reference frame to have different amounts of kinetic energy. If an object has zero kinetic energy in a particular reference frame, it must be at rest. At rest in that reference frame. For an object to have kinetic energy, it must be interacting with another object. Does it though? I feel like D is like kind of like not really. It doesn't feel right. The only thing I remember about energy is that I know it's conserved, and plus the equations for I guess like the height of potential, like the potential energy when it comes to falling objects, as well as the equation for kinetic energy. I remember those things, but the deeper essence I have to actually brush up on. So I do believe this applies. The kinetic energy is a vector with no, actually it's not, because I mean the vector component is the velocity component is a vector, but kinetic energy is supposed to be it's supposed to be a singular value, isn't it? Yeah, it's supposed to be a scalar, so it's not a vector. It's possible for two objects that are moving in the same speed, in the same reference frame, to have different amounts of kinetic energy. I mean, if the objects don't have the same mass, I mean, it's possible, but then again, I'm just thinking about the equation. I'm not thinking about the actual physics of it. If an object has zero kinetic energy, hence probably no velocity in a particular reference frame, it must be at rest in that reference frame. Huh. For an object to have kinetic energy, it must interact with another object. I think B and C make sense to me. But if we're wrong, we'll just learn, and we'll see why we get it wrong. Oh, this is correct also. A kinetic energy is a scalar with a magnitude only. It doesn't have a direction. Oh, they actually give you the reasons here. I didn't realize that. Why is this as correct though? Why does this also apply? Kinetic energy is a vector with the same direction. It doesn't have a direction. Yeah, but why'd they mark this correct though? That's the one thing I don't get. Let's see, an object can have kinetic energy whether it's interacting with another object. Yeah, this one sounded funny. I was like, that doesn't sound right. Okay, onward. Let's see, a free body diagram for an object is shown below. Right is the positive x direction, and up is, okay, so is the positive y direction. The object undergoes a displacement in the in the positive y direction while experiencing a constant force modeled above. So we got a positive here and a negative here. Rank the work done by each force during the displacement from most of the positive to the most negative. Okay. The object during the displacement. Okay, so we got a force that's pulling in this direction, and we got a force that's going on in this direction, and then a force in this direction. So B would have to be minus from these right here. So there's a zero in the x direction here. This one's pulling a little bit on the east side, so the x direction is going to have a value, but the y direction isn't. So this one, so practically it would be like FA plus FC minus FB because it's pulling in this direction. So these two forces look like they're like the most powerful forces here. Oh, you can move these. Well, these two forces, they're like perpendicular to each other. So this one will probably overcome this one because it's smaller. But then this one, it will pull it more towards like, so it won't be going in the x direction as much. So what does they have in this category? The object will slow down or move at a constant speed. I think it will slow down because it looks like it's going in the negative direction on this side. So it's like probably falling back. So I get a feeling it might slow down. So rank the work done by each force during the displacement. From most positive to most negative. So this one is going in the Y direction more. This one just basically, I mean, this one seems like it has the most. Would it be positive? I mean, in distance. Huh. I mean, in distance-wise, they would all be positive. They would all be positive numbers if you take the distance only. But for the work done, I mean, this would be like basically like. But then you also have to think about the angle here. The angle is probably the thing that makes it a little bit tricky. Let's see. Rank the work done by each force during the displacement. The most positive, the most negative. So, I mean, this one is going in the positive direction. And the most negative. That might not be right, though. I mean, based on the work done, though. If we get it wrong, then we'll have to learn. I'm just gonna say that every time. Yeah. Maybe a reference? Oh, it's the same one. So cosine. Because this one is just purely 0. This one. Maybe this one. No. Guess I have to take some hints. Let's see. Force does positive work if the force or the component of the force acts parallel to the object's displacement. A force does negative work if the force or the component of the force is anti-parallel to the object's displacement. Force does 0 work if it has a component parallel or anti-parallel to the displacement. Okay, so it acts parallel to the object's displacement. So these are like orthogonal to each other. Does negative work? So maybe this goes here. Oh no, this one, maybe this one's last. This one here? No, we had it wrong before that. So let's see, we're told the object's displacement is in the Y direction. Oh, okay. The object undergoes displacement in the positive Y direction while experiencing constant force modeled above. So FA acts with a component in the Y direction so that the component does positive work on the block. So does that mean that goes here? FB acts entirely in the negative, so it does negative work. Yeah. Let's see if that's it? No. So we didn't get that one right. Okay. A block of mass... Let's see. A block of mass M slides across a horizontal surface. The coefficient of kinetic friction between the block surface is mu k. The block has an initial speed of v naught and slides a distance d before coming to rest as an object as modeled below. Which of the following expressions is equal to v? Okay, so alright, so we're gonna have to do a modeling. Okay, so we got a kinetic friction between the block and the surface. So we got that variable. What happens if I shrink this? Okay, that looks fine. And can we work around this? Okay. Alright, so a block of mass M slides. So I'm guessing they're using the equation of kinetic energy, which is A equals a half mv squared. However, we also have to deal with friction here. So it's a force. So now I have to fit friction with this equation here. They have G and D in this formula too. Which means I get a feeling it's A based on the structure. We have this force of, let's see, and this is kinetic friction, I think. No. But then again, I haven't reviewed this in a while, so this means I have to go back to the basics here. Oh, sorry about that, guys. I get a feeling it's a square root, but then again, like, alright, so okay, so the mass doesn't matter. Is it because of the force from friction? Let's see the step-by-step solution. Let's see what I was missing here. let's see, we can use the equation for the work done by the force determine the work done of the sliding block. Determine the work done by friction as the block slides in the distance. So this is the work done here, and the difference between the kinetic energy is the one. Okay, V is equal to 0, so this goes away. And then we are left with this. And we express that. Let's see. So we know that Fn is gravitation. So mg. So that's the force of gravity. Substitute the expression into the equation. So basically, this shows that mass doesn't matter in this case. We only got like 2 correct. So let's see what they have in this example here. So this is the work energy theorem. So first I'll just pause my music and then we'll just take a look at what they have here.
States that the net work done on an object is going to equal the changing kinetic energy of that object, and this works for systems as well. So the net work done on a system of objects is going to equal the change in the total kinetic energy of the objects in that system. Now that sounds really complicated and technical, but I like to think about the work energy principle as a shortcut.
Just expand
this. This is a really nice shortcut that lets me determine the changing kinetic energy. So the work energy principle states that the net work done on an object is going to equal the changing kinetic energy of that object, and this works for systems as well. So the net work done on a system of objects is going to equal the change in the total kinetic energy of the objects in that system. Now that sounds really complicated and technical, but I like to think about the work energy principle as a shortcut. This is a really nice shortcut that lets me determine the changing kinetic energy without having to do a bunch of complicated conservation of energy equations or kinematic formulas. The catch is that I need to know how to figure out what the net work is. So how do you figure out net work? Well, the formula for work done is FD cosine theta. Since this formula, work energy principle, relies on net work, this has to be magnitude of the net force times magnitude of the distance traveled times cosine of theta. Remember, this theta has to be angle between, not any angle, angle between the net force direction and the direction of motion. And so let's try this out. How do you use this thing? Let's kick the tires. Let's say there's a satellite, it's moving to the right, and there's a net force on this satellite. Now this net force could go in any direction. If the net force has a component in the direction of motion, then the net work's going to be positive. And if so, anything here from like negative 90, well, I guess like negative 89.9, because 90 would be perpendicular, from anywhere from like 89.9 negative to positive 89.9, you've got a component in the direction of motion. That means you're going to be doing positive net work, and that means the change in kinetic energy will be positive because it just equals that number. That means kinetic energy increases, you're going to be speeding up. And that kind of, it makes sense intuitively. If your force is in the direction of motion, you're speeding up. What about the other case? What if your net force points in the opposite direction of motion? Well, now the net work's going to be negative. You'll have a negative change in kinetic energy. In other words, you're going to slow down. And if the net force points perpendicular, well, then you're not doing any work because cosine of 90 is going to be 0. No net work would be done. There's going to be no change in kinetic energy. That doesn't mean you stop. It just means you're not going to speed up or slow down. This does something. You might be like, doesn't it do something? Yeah, you're going to drift upward. You're going to start changing your direction, but this is not going to be doing any work on you at that moment. And so just to be clear, let me let's just try a complicated one here. Let's say this force goes in some direction. Let's say your velocity even goes down. So maybe your satellite's heading downward and your force is going to go in any direction. Well, if it goes this way, exactly backwards, it's going to be 180. You're going to be doing negative work. You're going to be slowing down, decreasing kinetic energy, and you're not going to change direction. If you're like this, you have a component opposite, so you're going to be slowing down and changing direction.
Okay.
This will just be changing direction. You're not speeding up or slowing down at that moment. This will speed you up and change your direction. And finally, this will just be speeding you up and you will not be changing your direction. So the work energy principle is convenient to just get a conceptual or qualitative idea of what's going on. And it can obviously also give you an idea of how to calculate things. So let's try one where you actually have to get a number. So let's say there's a hot air balloon, and it's a 300 kilogram hot air balloon drifting to the left. It had an initial speed of 7 meters per second, and it's traveling a total of 50 meters to the left during this journey. Now there's going to be forces on this hot air balloon. Obviously there's going to be gravity and some buoyant force, but because these are perpendicular to the direction of motion, they do no work. And so when we're going to use this work energy principle, they're not even going to factor in. We don't even have to know these since they were perpendicular and did no work. You only consider the forces in the direction of motion. So say there was a wind gust helping you to the left here of 200 newtons, but this is a big bulky balloon, not that aerodynamic, and so there was a drag force from air resistance of 104 newtons to the right. And what we want to know is, we want to determine the final speed of the hot air balloon after it travels 50 meters directly to the left with the forces shown. Now there's lots of different ways to do this.
Okay. Maybe we should pause and actually try to do this one. Okay. Let's shrink this. I think we can turn the music for here so that we can actually just try to use our brains a little bit, because usually for me I like to actually just do straight into the problems and see what we can do. So it says determine the final, I know it's very tiny, but it says determine, I'll just rewrite it here for you guys, so hopefully, oh no, I have to write much further here. Okay, so now I know where my pen is at. So determine the final speed of the hot air balloon after it travels 50 meters directly to the left with the forces shown. Okay, so I'll just redraw it. So we'll just have the balloon here. I know it looks like a tree or something, but I don't want to go too much into detail. Okay, so we have a mass of 300 kilograms, and we have a gust wind force, which is 200 newtons. Hopefully you guys can see that. And it's going 50 meters, so that's the distance. So D equals 50 meters. And it has a drag force drag, which equals 104 newtons. Okay, determine the final speed of the hot air balloon after it travels. So the equation we had before was that the difference is the summation of all the work. And for the equation for work, we had the force times the distance cosine theta. Okay, so I think theta in this case is let's see, we got work in this direction, so it's practically the angle between them is practically like 180 because they're going in opposite directions, which means it's probably going to be negative in this case. There's one more detail in here. What is that? Oh, the velocity is so the initial velocity is 7 meters per second, right? Yeah, 7 meters per second. Don't want to miss that detail. Okay, so there's two thetas, I think, because there's two forces here. So the work conducted on these two. So I think there's going to be two thetas. So in this case, let's say work 1 is, the force is 200 and the distance is 50 meters. Then cosine, well actually I should write the units. I think it's better because we're doing physics, so we should write the units down. So we have 200 newtons times 50 meters cosine of 0 degrees. So it's just going to be these two together. So, okay, I got my calculator. Oh, actually, I can do my calculations right here with you guys. So, let's try this new. I haven't tried this, so let's give this a try. Times 50 gives us. What was the unit for work? Dang it. Is it joules? It's joules, right? Because then, like, newtons, so I think it is joules. If you guys are watching this on YouTube, correct me in the comments. Actually, like, that's gonna bother me. I don't like it when I get the units wrong, so units for work. It is joules. Okay. Sometimes, like, I hate the fact that I forget small details, but then again, I haven't touched physics in a long time, so I have no one to blame but myself for that. Okay, so we also have a gust of wind, so the work done from the wind is negative. Oh, that looks ugly. So meters. Oh no, newtons. And wait. Oh, maybe I should do it the other way, because technically the other way is the positive direction. So first let's erase this, and then we'll just do, well, they're gonna cross out anyway, so the negatives are gonna cross each other out. And negative 50 meters, because it's in the opposite direction, and this one is going to be 180 degrees. And thus, we're getting a negative and a negative, which makes a positive. Thereby Hello, Sasha. How's it going? What's the best part of your day so far? And we have an unwanted guest, so you're going bye-bye. But Sasha, you're free to stay. We're just doing some basic physics, and I'm basically just getting into problem solving. 50. Oh man. Gotta click the tablet. Yeah, we're just doing a little bit of Khan Academy. Not sponsored, by the way. I just feel like I should do it because I'm trying to change my study routine, because I then had a deep thought with myself, and I'm like, if I don't learn anything from my notes, then how should I study? And I think that I should just jump into problem solving. Oh wait, I could do it from here. I could show you the calculation from here. What am I doing? So clear. Let's do 4. And I think we could do times 50 because it's -1, so that will cross out the negative there. So, whoops. Times 50. That gives us 52 joules. So we have this side done, the work. So the work I. So then these plus each other plus 52 joules. Well, 5200 joules. Okay, so now we have to think about. So now we have to remember that the initial velocity is 7 meters per second. So that's going to play a part. And the mass is 300 grams. 300 kilograms, my bad. So we know M is 300 kilograms. Oh, that's... Well, actually, first let's write all the variables for you guys on the right side. 300 kilograms. Oh, I don't have to write that S there. I don't know why I wrote that there. Oh, it's already break time. Dang, when I get deep into a problem, I forget that it's break. But I think we're making progress here. And then we'll probably retake the kinetic energy quiz again, because we only got 2 right in that quiz. And actually most of that was mainly comprehension. But then again, like, I still have yet to learn a little bit more about kinetic energy. But while we're on break, what's the best part of your day so far, Sasha? Any developments with your research? And actually, like, if you guys are watching this on YouTube, like, for all those that basically drop a subscribe on YouTube, thank you very much. I always, like, feel empowered whenever you guys, when you guys, like, watch my stuff. I know, like, you know, like, not a lot of people, like, find my stuff, like, I guess, like, very informative, because I'm just basically doing basic stuff. Not to mention that I will get answers wrong a majority of the time. But, you know, I guess, like, this channel, like, the channel itself is, like, my kind of mathematical journey. So I will run into a lot of pitfalls. But I think that's basically the point of the journey, is like you basically see when you fall and when you fail, and then you learn from your mistakes. I think, like, when I revisit, like, physics, I kind of get reinformed on how, like, I don't want to say something negative about myself, but it makes me understand, like, how much I don't know. And, you know, like, whenever I get back to the basics, even though I know the equation for, like, kinetic energy, that doesn't mean I fully understand what it is. And, like, doing those quizzes, like, I mean, the quiz was only 4 questions, and, you know, like, what does 4 questions tell you about what you know about a certain subject? It doesn't really tell you much. But, like, for me to only get, like, 2 answers right, I felt like with that quiz, I didn't really do well by, like, my knowledge of, like, kinetic energy. The only thing I remember about kinetic energy is that basically it's the energy that happens when something's in motion. And you know, like I always think of it as like the Lagrangian, where it's like kinetic energy minus potential energy is usually the energy is usually the Lagrangian, where you integrate it and then basically it gives you the action. But at the same time, like, even though I kind of know like I guess like the quote-unquote equation of that, or like how it's made, it doesn't mean that I fully understand what it encapsulates. So, you know, like I think like, yeah, doing physics problems is the way for me to actually engage with the material. Like, even though I've done like many physics problems in the past before, like I still think about like, what is it that I need to do to update my study routine in order to make all this stuff stick. So it's like, maybe I just have to continuously do problems for like a majority of my free time. You know, I mean, like, for me, I'm still trying to discover what my study routine is, so it doesn't feel as if like, it feels like I'm actively learning instead of just passively learning. And I think like throughout my life, like, and I'm pretty sure you guys have experienced this too, is like when you have school, you passively learn sometimes, and you think you know something because you read it in the textbook many times and you can recite its definition by heart. But at the same time, you also have to remember that, like, sometimes I guess you kind of know like the definitions, but you don't fully grasp the concepts. And usually the stuff like that comes with just constant practice. I guess for me, it's like I have to constantly like see that I'm constantly getting things wrong, and then I have to look at the solution and then try to learn from the solution. But at the same time, I also have to understand why that solution is what it is, because like you can also fall into the trap of like, oh, I look at the solution and it makes sense to me now, but that doesn't mean that I know how to solve the same problem with different numbers and different parameters. Because I do have a habit of just memorizing stuff, where it's like, oh, I look at the solution, oh, that's how they did it, and then I memorize that solution and I do it to the same type of problem. But that doesn't mean that I know how to solve a problem with a little complication in it that involves the same type of techniques. I'm pretty sure like a majority of you guys, whether you're watching this on Twitch or watching this on YouTube, go through those type of scenarios. Like, you're basically constantly questioning yourself on whether you fully understand something. And the thing of it is that when you do these topics, sometimes you really don't fully understand it. Like I think like you grow into a custom that you're not going to understand 100% of everything that you learn, but you will learn like, I guess, like the surface value of what it is, unless you research that stuff like in depth. Which I think is the reason why like there's like professions in math and physics that people never heard of, and like they're like, what is that? Like, you know, like what is a geometer? Like, what type of mathematician is that? Or like what is an algebraist? It's like, oh, I just do algebra for a living. Oh, it's like the one in high school. It's like, no, like real algebra. Like you know, like for those of you that basically love math and physics, like, I wish you luck and keep going. But at the same time, I hope you find the study routine that actually helps you learn actively, not passively. And I think with math and physics, like, you can learn actively. The thing of it is that it's harder to actually know when you're being actively learning when you're reading the textbook, because like you're obviously taking notes on like what equations there are and how these equations work, or how they're supposed to be applied, or how they're supposed to be solved. At the same time, like when you actually do the problems, like sometimes they add a little tiny tricky complication in there, and then you have to think about like what the complication does and what you can do to get rid of the complication in order to solve it the natural way. Well, I say in a natural way, but the way they kind of expect you to solve it. Like, you know, the inverse of addition is always subtraction. And sometimes to solve x, you have to do subtraction on the right-hand side or the left-hand side. It's just that's my simple way of actually like thinking about that. or like trying to explain it, what I mean. Because like I think for me, I'm debating on whether my study method lets me actively learn or it lets me passively learn. Because I think when I learn passively, it just feels as if like I can read stuff and then it just feels like it's understandable because of the words that I read in the book. Because it kind of presents it in a way that like, oh, I understand that example, or I understand that analogy that they're making there. But at the same time, is that actively learning? Well, the answer is probably no, and I have to be honest with myself about that. And usually I like to read because if I passively learn through reading, it lets me retain it a lot better. But at the same time, I'm not actively learning because I'm not engaging with the material. It's like when you're doing math proofs, like you can read about the definitions, but you have to know how to apply those definitions to the proof in order for your proof to actually have solid sense. And that's why I think mathematical proofs are not only hard for me, but also hard for people that are actually doing them. Because they're not easy. And the reason why they're not easy is because you're trying to prove an argument. And those arguments are usually like pretty tough to prove because you're trying to make an idea out of practically just definitions that you read in a book. And sometimes those definitions are based off other theorems that were proven by other definitions, which is pretty much like, I guess, like pretty much like discoveries that other people made with their math proofs. But yeah, I think like I think the fun of learning is just basically being able to find your own study routine. And I guess for me, I'm just still trying to discover exactly what is it that I need to do to actually fully know the material and like have it in the back of my head, while not struggling to actually try to recollect everything. And if you guys like hear like it sounds like I have something in my mouth, it's basically a cough drop. I always have cough drops whenever I'm streaming because I know I talk a lot during streams, especially with these videos slash streams. I call them basically saying videos because you guys could be watching on YouTube. And if you guys like math, physics, or you just want a productive stream to keep you guys productive and doing the things that you're doing on your computer, if you're watching this on YouTube, drop a like, comment, and subscribe. If you're on Twitch and you're just lurking in the chat, please drop me a follow. Much appreciated. It always helps out build the community, as well as let us just like love math and love physics the way like we wish to express our love for it with other people. I mean, like, I am grateful to you guys that actually watch like my videos like on YouTube, because I checked one of my videos, and I know I shouldn't check the numbers, but when I saw like one of my videos had like 117 views, I was like, wow, that's crazy. And for me, I always never thought I was entertaining. I just thought that like doing those, like posting my VODs on YouTube, I always thought that, oh, this is something like my own personal I guess journal of the journey. But I never thought that I would get 100 views on one single VOD, and I thought that was pretty crazy. And plus, whenever I see the subscriber number go up, I'm always happy because it makes me feel like I'm reaching to some of you guys out there. So I have to say thank you to you guys, because you guys actually helped me get to affiliate on Twitch. So I personally feel like I'm empowered to actually continue learning math and physics, because you guys continue to give your support, and hopefully your own mathematical and physics journeys are just as good, or just as rewarding, I should say. Because I know you're probably gonna fall into massive times when you're stuck, just like I do. Because sometimes when I feel like I love the subjects, but at the same time I don't do enough practice on problems to basically say that I'm good at it. I mean, you could type what you feel like on your own mathematical / physics journey down in the comments down below, and let me know exactly what are the struggles you're going through. And I think that I can probably understand a little bit, especially when you're like at a point where you plateau and you just don't know what is it that you're lacking. We are a positive community here, and I really want you guys to feel encouraged. That's why I'm willing to put all my mistakes on stream / on my videos on YouTube, because I am not perfect. I am not a student. I'm just basically constantly just learning the stuff that I find interesting. You know? So that's something to keep in mind. And, you know, like whether you're struggling on algebra or calculus or just pre-calc, find a study routine that allows you to actually engage with the material, but also ask questions. Like, ask questions on like when this idea breaks, because I don't do enough of that. I don't do enough of like basically trying to see where does this idea break down, like what is it that I need to do to this particular equation or this particular system to see where it fails. I mean, that's usually what experimentalists can take for granted, because they have so many materials and they can like mess around and see what happens, and they just have the evidence like in front of them. It's like, well, what happens if I add this water to this particular substance? Or what happens if I add this type of fuel to this rocket? You know, these type of questions, like, we're afraid to do them because, like, you know, either it's going to cost another company money or we're just going to wreck the thing that we built and we worked so hard to build. But sometimes that's when you learn the most, is when it just wrecks and fails. Okay, so we're almost to the end of our break, and then we're gonna restart the clock. Maybe I'll try, like after I try to solve this problem, I'll probably continue watching the video here on Khan Academy. But first, I need to use the restroom, so I will be right back, guys. Give me a second. Okay guys, I'm back. Okay, I think we'll start the study timer again. 45 minutes. Let's see if we can complete this problem and hopefully we do it correctly. So we got the amount of work done, so that's the initial velocity. So the point of the problem we have to do here, let me just move over here. My mouse is on my other screen here. Okay, what is the final speed of the hot air balloon? So basically, I'm guessing the way this is structured is that we have mass, velocity final, minus initial, and then we have the work done on this side. So I think what we need to do is that we just have to move these variables around. So we can factor out an m and a half. So then we have these. And then we can multiply 2 on both sides so that we can get this. Then we're left with m. Then we can divide m on both sides. subtract erase that, and then we subtract the initial speed squared. So joules, I have to remember the units. So the unit for joules is newtons meters, and newtons is kilograms meters per second squared. Yeah, because it's yeah. And then we're having meters squared because of the meters from the distance here. This is going to be over kilograms. So we multiply, so kilograms will go away. I'm trying to see if the units make sense. I just don't want to get like weird wacko units, like, because I mean I know the numbers are gonna work well. It's just that the units I'm concerned about, just in case. And to get the final speed, we have to do all this. What fun. Okay, so we got the setup, and I think we got all the variables. So now we just have to do the math. So we got 2 times, what did we get as the total for the, oh wait, I keep pulling out my calculator next to me, but I also have a calculator on the computer. I don't want to leave you guys out of the calculation. Okay, so let's clear that out. So we have, so it's 10,052 times 2, and then that divided by the mass, which is 300 kilograms. And minus the velocity, the initial one, and then where's the square root button? Where are you? Oh, there you are. So second, square root, answer. So then that leaves us with the square root of, 7 over 3. And that would be meters per second. Now I just want to make sure I did all that correctly, just so that we're not so let's do just this, and then we'll add another parentheses, then another parentheses. So 2 times 152 sure that I got my numbers right. Yeah, 1052. And then divide that by the mass, which is 300. And then parentheses. And then minus. Oops. The initial velocity is 7 to the square. Okay, everything looks right. Oh. Which parentheses did we miss? So we got this parentheses. So this parentheses. So I think we need one more. Yeah, it's the same one. Okay. Alright. So I guess that's the answer. Because we have, yeah, we did that. The initial velocity, we got that. And we did include it squared, so yeah. Right, yeah, so we did that. Yeah, the algebra looks right. So let's see in the video if that is correct. I'll write it in decimal places, so that way, because I don't know if they're gonna do it to the decimal places or they're gonna do it like the way we have it. So let me just erase this part here, and then it also is equal to 7.732. So that way we have it in both forms. If I'm wrong, then I'll have to accept the fact that I was wrong.
Newton's laws, you can do kinematic formulas, all kinds of stuff, even momentum technically, impulse, but the easiest, I'm pretty sure the easiest way to do this is just going to be the work energy principle, which states that the net work done is going to equal the change in kinetic energy. So let's go ahead and do it. So we know that net work is equal to the magnitude of the net force times the magnitude of the distance traveled times cosine of the angle between them. What's change in kinetic energy mean? Well, change in anything is final minus initial. So since kinetic energy is 1/2 mv squared, this is just going to be 1/2 mv final squared minus 1/2 mv initial squared. So this is going to be the change in kinetic energy, final minus initial. All right, let's plug in numbers here. So net force, how do we get that? Vertical pieces don't matter. We're just looking horizontally here. Those are the only ones that are going to affect it. These vertical ones just cancel. So we have 200 to the left, 104 to the right. So we're going to have to subtract those to get 96 to the left. And we just took magnitude, so I'm going to get
sensation.
96
What's the best part of your day so
to
far?
the left, not negative or anything. I'm just taking magnitude. Times the distance traveled, we know that's 50. So we get times 50 meters. Cosine of the angle. Now this is careful. You might be like, oh, 180 here, but no. The net force points to the left. This 200 is winning here. So leftward net force and leftward direction, the angle between those two is 0. Cosine of 0 is just 1. We're maxed out here. So
hey,
net
Jeff
force
Bros.
points in the direction.
I'm hunting scammers. Oh, I see.
1/2. The mass is 300 kilograms times.
I'm gonna have to say getting a good workout and streaming for you guys, Jeff. Thank you for asking. What's the best part of your day so far?
Times the initial speed.
Yeah,
is
I think
7.
we did a raw. We did get an error. Yeah, because we. Yeah, because they basically subtracted the two forces. Yeah, they subtracted the two forces. Well, technically they added the two forces because this one is going in the opposite direction. Dang. I thought I actually did something right, but unfortunately I missed it. I missed it by just one tactical error. Because what I did was the summation of work here, but then like with these forces, yeah, because like we did the two negatives here. Because I usually think of the left as the negative direction. That's why I put it that way. And then this way, yeah, because we also got cosine and doing that, then yeah, because that would be -1, and then, yeah, I did that incorrectly. Oh well, I guess that's something I have to learn. I think like when I feel like I do something right, but then I realize it's wrong, I'm like, oh my god, I hate that feeling. But then again, you got to experience that every time, because that shows that you have a massive gap.
10 meters per second. So we got 7 meters per second.
Oh wow, workout. This
well,
this is the best part of my day, relaxing with a mass stream. Right.
That means
cool.
That's the net work done. Notice
I'm always lurking in everyone's channels, and whenever a message is deleted by
the change in kinetic energy.
comes up, it pings me and tells me to take a look. Oh, I see.
That's gonna have to equal half of 300.
Because you're also a mod for actual education streams, right? On Sensation.
V final squared minus, if you take a half of 300 times 7.
Yeah, I got the wrong total.
You're gonna get 7350.
Dang.
So this is how much energy the hot air balloon started with initially. So I have to move that to the left. We add those together. I'm gonna get 12,150 joules is how much kinetic energy the balloon ends with, and that's got to equal 150.
I mean, we got the technique right, at least.
Squared. I could divide 12,150 by 150.
Among others, but yeah. Oh, I see.
81.
I see.
And that's going to equal V final squared, and if you take a square root of that, you get exactly 9. So the final velocity of this hot air balloon is 9 meters per second. It's sped up. That's not surprising. This net force was directed leftward, and the object was moving leftward. So we're doing positive work. We're increasing the kinetic energy.
Okay, so what did we learn from this? We learned that we basically have to do the summation of the forces first before we actually do the work, the net work calculation. I mean, that's usually what comes when you're trying to relearn something that you felt like you had a grasp of. But it's okay. It's okay. At least I think that's usually how it is sometimes. That's why we study, right? That's why we study. Okay. Yeah, so I don't know if this is going to give the same questions. Do they give you different questions? Like every time you retake it? Okay, no, this is a different one. Okay. So let's see what we got here. A constant force F exerts continuously on a block that's initially at rest. Oh, I forgot my music. Let's see. A constant force F is exerted continuously on a block that's initially at rest on a horizontal surface. The block slides with negligible friction for equal distance. Okay, so the question is the same. It's just that they made a different parameter for it. So let's see. Complete the statements of the two intervals D1 and D2. Okay, the work done by force on the block is equal. The change in the block's kinetic energy is, I think they're all equal. It is the same question, but it's just making you answer it a different way. The change in the block speed is equal. Let's see, the work done by the force on the block is equal to the two intervals. The distance, the change of the block's kinetic energy is, yeah, that's from the work energy theorem. So yeah, the change in the kinetic energy is equal to the two intervals. The change in the block speed is equal to the two intervals. Yeah, because there's going to be a change in speed from like the initial and the final velocity. Compute the kinetic energy in its own. Okay, let's see if that is it. Yeah, there we go. Changes the block speed is not equal to the two intervals. Oh yeah, that's right. I think that's we didn't mark that one during the first time we did it, because like the first time it was like mark from A to B which one is correct given the scenario. Okay, so I could have gotten that one wrong actually. Thank you, Jeff, for like clarifying that. Although I don't know if I cheated with that. I'm here to annoy, but sometimes I help. That's fine. I just worry about myself cheating sometimes, because like you probably like understand this better than I do. So it's like, it's okay. But sometimes I worry about cheating myself with you guys' help sometimes. That's why I put that rule there. Assume kinetic energy refers to translational kinetic energy. An object can have kinetic energy even if it's not interacting with an object. I think that's yes. If an object has zero kinetic energy in a particular reference frame, it must be at rest in the reference frame. If two objects are moving at the same speed in the same reference frame, they must have the same kinetic energy. I don't think that one's right. Let's see. Kinetic energy is a vector with the same direction as velocity. No, it has the same magnitude, not the same velocity. So an object is... I think that's right, because then basically it's not speeding up. I mean, it's like if it has zero speed, if it's like zero kinetic energy, then there's no velocity. Or either the object doesn't weigh anything, or doesn't like have a doesn't have a mass to it. I think I know the answer. Hey, FemVox fan. What's the best part of your day so far? If two objects are moving at the same speed in the same reference frame, they must have the same kinetic energy. I don't think that's right, because we don't know if the two masses are the same. That's another thing we have to take into consideration. But then again, no, I think it's the same. I think I'm right on that, but we'll see. Yep, we got it correct. I don't know why this says it's correct though. Because it's like it has a check mark that say you could check it off, but like, do you guys know why? Because it even says here, it's like kinetic energy is a scalar quantity with magnitude only. It doesn't have a direction. So I don't understand why this is correct. I'm doing physics today. Oh, okay. You probably know more stuff than me then. FemVox fan. Well spotted. I think A, B, and C hasn't realized mass could be different. Dot V, yeah, right. Yeah, I don't know why they put this as correct though. Like, why do they put this as correct? I don't get that. That's the one thing I don't get. Because this is incorrect and this is correct for some reason. You only got D wrong. Yeah, and it basically says that kinetic energy is a scalar quantity with a magnitude only. It doesn't have a direction. So I don't get why this is marked correct. Unless they made a mistake and it's supposed to be incorrect. Yeah, this one I didn't get the last time. Let's see, a free body diagram of an object is shown below. Oh, they changed the diagram now, so the diagram is different. Let's see, right is the positive X direction and up is the positive Y direction. The object undergoes a displacement in the positive Y direction, so it's going this way. While experiencing a constant, the constant force is modeled above. Okay. Rank the work done by each force during the displacement from most positive to most negative. Okay. So I think we have to sum up both these forces. Yeah, because I think we have to sum up these forces now. Oh. I thought I dropped something. Okay. Let's see. Alright. So we have to move. We have to do the most positive to the most negative. Okay. So we would have to add these two forces together, which technically they would just be added up together. So it would be -2, and then we have 1, 2, 3. So we have like -2 and 3. Well, technically the force between these two things, the angle between them, and then we have this thing here, which is, let's see, this is 1, 2, 1, 2, yeah, 1, 2, 3, 4. So technically we can just basically put these together. Where's my calculator here? So clear that. So we would have, let's see, 2, -2 plus, yeah, because then we have -2 here, and then we have +3 here. So that -2 plus 1, 2. So that means it would be 0 here. So it's 0 in this direction. And then for this one, we have -1, 2, 3, 4. So -4 plus 3 and Y. So it'll be -1. So it'll be 0, -1. So that's the total of all those. Let's see. So we have to do the most positive to the most negative. So work is usually done when they're parallel to each other. So these two are not really doing work on each other because they're like orthogonal to one another. So F, B, and FC are probably doing, but then again, FA and FC are also, so I think this one's not doing that much work. Sure, Jeff Bros, if you want to give a hint. Because I think FB is not doing much because it's orthogonal to both of these. I mean, sort of orthogonal. Compared to like FC, I mean. But it's orthogonal to FA, so I don't think it's doing much work here. So I think this one might be the most negative. I think the direction of the object is moving is irrelevant. Work is for, yeah, that one I know. I know it's force times distance, and if there's an angle between them, then basically you have to take account the angle of it. So let's see. And it has a displacement in the positive y direction, so it's going up. So I think, so rank the work done by each. So basically this one is probably like 0. So this one probably goes here. And I think this will be the most positive because it's right here. Let's see, complete the statement. The object speeds up, speeds down, slows down, moves at a constant speed. So there's a force now. So the object's displacement during the... So... Because work is force times distance. So how much the force is going. So there's a bigger force down here. And if you do the distance of that, I feel like this is gonna slow down a bit. Let's see if that's right. Maybe not. Oh, we got it. Cool. Because I feel like it would slow down because like this force is bigger. Okay, we got 3 right. Okay, here we go. A block of mass m slides across the horizontal surface. The coefficient of kinetic friction between the block and the surface is mu k. The block has an initial speed of v naught and slides a distance d before coming to rest, as the model below. Which of the following expressions equal d? Okay. So I guess we're gonna have to apply the energy theorem. Well, the work energy theorem, I mean. Because we have friction in here, so it involves forces. Okay. So let's see if we can do this. Okay, so kinetic energy is equal to mass times velocity, and it's a scalar, so just put a little. Well, actually, let's make it easier to see, so that way we don't have to deal with other nonsense. Now, we have to calculate distance now. So, I'm guessing, basically, this is going with equals the summation of the work. But we also have, the summation of the work is also of the forces, distance cosine. So the summation of the forces, so a force, which is like the thing that's like pulling, I think. But then we have to minus the friction there. And just for mass, and we'll just say that we'll just basically say that V naught is equal to, oh no, it is, there is an initial speed, so so we have half V final, half V naught. Okay, slide across there. Oh, they have G in here. Wonder why they put G in here. Because it's going horizontally, it's not going like up and down. I wonder why. Like the force of friction. And then times the distance. And I think we'll just make cosine like equal to 0, so we don't have to worry about doing an angle. So we'll just put theta is equal to 0. And we do have an initial speed, so we can't take that out either. So I mean, I want to factor these out. Oh, I think they made a V final 0. Because there's no V final in there, so I think we can just take that out. That will make it much easier to deal with. So now I think we have to simplify what F and F. So mass times acceleration. And minus no, because that's just the coefficient. It's not an acceleration. I don't know why I was thinking it was acceleration for a second. I was like, no, it's just a coefficient. Acceleration of friction. Well, maybe that's where the G comes from. Then we have Hey Famish, how's it going? What's the best part of your day so far, my friend? It's going alright. It's a nice day outside. Actually, like probably after stream, I'll probably try to walk. I'll probably try to go on a walk, so that's something to look forward to. Yeah, we're just basically doing physics through Khan Academy. Not sponsored, by the way. I'm just basically felt like I have to practice. I mean, we got some problems wrong, but you know, you can't get everything right, right? And that's the learning process. You gotta accept when you're wrong. No, it's okay. Holly is human. I like that. Let's see. I'm just reading your message because it's a bit big. I mean, like, you know, like, thank you for actually, like, hanging with us if you're about to go to bed soon, Ali. But, let's see. Knowing I sometimes fluctuate my level knowing and applying math, and sometimes my mind makes me feel. Yeah, I mean, I think that's like the imposter effect, because I love math, but at the same time, I'm not really great at it. At the same time, like, I love physics, but I'm also not great at it. So, oh, no problem. But yeah, like, if you guys like math or physics, as well as, like, you know, just need a productive stream, drop me a follow if you can on Twitch, or if you're watching this on YouTube, subscribe to my YouTube channel. Yeah, so I think that's gonna, like, I think when you feel that way, just feel as if, just like acknowledge the fact that you're not supposed to be the smartest person. Just take it as if, like, oh, I'm building up my skills so that I can help someone, even if it's like just to get a small step to whatever discovery they want to make or where they're gonna aim to get. So just don't think like, oh, I have to get up to like Einstein's level, or I have to get up to like the level of, like, you know, some of my peers who are probably better than me at math and physics. I would say, like, just basically say, I'm gonna do the best that I can so I can help them make the discoveries. Like, you know, like, if they're better than you, I usually think of it this way. I usually think, okay, I'm not at their level, but at least I'm going to get to a point where I don't become a hindrance to them. So I can basically, like, understand what they're talking about, even though I may not understand, like, say, like, 70 to 90% of what they say, but I want to be able to understand the 10% of what they know. And I think that usually helps a little bit. I mean, for me it does, because, like, it gets me out of my own ego. Hopefully that helps. Because I know imposter syndrome is a big thing when it comes to, like, dealing with, like, stuff like that. So I think we can factor out M here. So we have MD here, and then acceleration minus... I see, thanks for that. It's cool insight. Yeah, I think that's the only way you can keep yourself sane from like, all that nonsense, I think. But yeah, hopefully that helps. And, like, you know, hopefully you can go to bed with that in mind. Because, like, for me, I jump around from different types of math and different types of physics all the time. And, you know, it's a really big blow to my ego sometimes when I realize that there is a lot of stuff that I don't know. So, yeah, don't feel too bad. I think that's just gonna happen anyway. It's just that, like, it gets a little bit easier to deal with the blows, like, whenever the feeling comes up. Thank you, Ali, for the follow. Appreciate it, man. Appreciate it. So, well, D is supposed to be equal to kinetic energy, then M minus mg. So we can actually actually factor out. Well, actually, we can like flip the 2 around. And we can take the m out like this. So maybe in this case they're assuming that there is no so basically there's probably no change in acceleration, so basically this force is gone. So maybe they made the acceleration 0 because there's no force. They're just basically pushing it at a constant speed. So basically the force of friction is... Okay, so then this will be negative. And then we are left with 2... I think we're close. It's just that I wanna get rid of these for a second, because this was originally like this. Then we had a negative here, and then right here. So then we're left with V over, and then underneath here. Right. So then it would be like V. 2 times. Okay, so I think that is the final result we're left with. I see. That's a cool insight. No problem, no problem. Oh, I already read that. Sorry about that, guys. I just love it when I read a positive message. So what we have here is v to the squared. So I think it's this one. So check. Yeah, we got it right. Nice. Oh, we reached the level up. Okay, okay. It did ask some of the same questions, but I approached it a little bit differently. So at least they asked like some things differently. So, but we managed to get all 4 correct. I mean, the first one, thank you, Jeff, for actually pointing out a fact that I probably would have gotten wrong. But like the second one, the third one, and the 4th one, we managed to get done like on our own. So I think that's I think that was a success. Okay, so I think that's it for today's study session. Thank you very much, guys. I guess we finished a little bit on time. But yeah, thank you for joining me on today's journey. And I think I'll probably do this from now on, because it feels as if I'm actually, like I said, I'm not sponsored by Khan Academy, but I felt as if, like, in order to get better at the basic stuff, I have to actually like face the fact that I just don't know how the questions work with the basic stuff. So I hope you guys enjoyed this little journey, or this part of my math study habit journey, because I'm actually trying to change my study method. So instead of just basically fixating on just reading the facts from the book and then doing the questions, I feel as if that I should try to like test myself on the things that I think I know, and then basically just try to do questions right away revolving around the stuff that I think I know. And if I get them wrong, then that means I still have a gap somewhere within my learning. So but I don't think I'm going to go linearly. I will probably like jump around a lot. So like today we covered kinetic, the relationship between work and kinetic energy. But maybe next week we'll probably just jump around, and we'll probably like do something that's a little bit different. I don't know if I will do through Khan Academy next week. Maybe we'll try to dip in a little bit into Brilliant, but who knows? Who knows? Like I said, I'm not sponsored by any of them. So thank you guys. If you wanna if you want to sub to my YouTube channel where I will post the VOD, you're more than happy to do so. Because I usually post my VODs there, so like in case you miss a part of it, you can basically check the rest of it out on YouTube. In addition, if you would like to learn math and physics with us, or just talk about your latest ideas concerning whatever thing you're researching within the subjects, or just want to talk to us about, you know, how we're doing, what our interests are, and get to know our community, you're more than happy to join our Discord server. And also, I will be streaming on my gamer channel tonight, so if you want to follow my Uncle Talks Twitch channel, you're more than happy to do so as well. So I think that's about it. Let me see if there's anyone we could raid today. Spread the love of mathematics. So let me see if there's any of our math enthusiasts online today. Well, Don does math is streaming. He's doing, I guess he's playing DayZ, so I guess we can give him a raid, because I always love raiding into his channel. So I will type in the raid message so you guys can copy and paste that. Oops. So copy and paste that, copy that, and we will prepare a raid into Don's channel. So here we go. Alright, the raid has been set up, and thank you guys for joining me today. And always remember, everyone is precious. You guys are just as precious as everyone else, and I will see you guys on Don's channel. So take care, guys. Bye-bye.